enter Boltzmann Brains. And as far as I understand the problem, it's that fully formed brains with memories, feelings, etc., can spring into existence due to quantum fluctuations in space or particles moving around randomly in the vacuum during a state approaching thermodynamic equilibrium. And while this is predicted to happen exceedingly rarely, in a universe that has no end, like ours presumably has, these brains are still expected to spring into existence infinitely more often than those that arise naturally in the earlier history of the universe, like ours, which makes it much more likely than that we're in fact Boltzmann brains than bona fide natural brains. Is this the correct gloss, or how you two would put the problem?
Well, it's not. I think that's close to the language in which the problem is often put. But I think the way you just put it is incoherent. Okay.
Okay.
The claim was that an argument can be constructed to the effect that we have good reason for believing ourselves to be Boltzmann brains, okay, or to be overwhelmingly likely to be Boltzmann brains. And the argument was just the one you just described. The argument would go, we have good empirical reasons for believing in such and such fundamental laws of physics. Those laws of physics entail that there will be many more Boltzmann brains in the history of the universe with my current phenomenal experience than there are what you naturally arising brains, or brains that arose in the way we think is usual with that set of experiences. And it's therefore overwhelmingly likely, if you apply elementary principles of self-locating probability, which we were talking about before, that makes it overwhelmingly likely that we are Boltzmann brains. This argument, as you just stated it, and this part I think Sean will agree with, this is incoherent, okay? Because if you find yourself concluding that you're a likely Boltzmann brain, one of the things you're committed to is that all the reasons that you think you have for believing that the laws of physics are what you believe them to be, your memory of textbooks you've read, your memory of experiments that were carried out that confirmed this or that fundamental theory of physics and so on, those are very unlikely ever to have actually occurred. Okay, it's not so the idea that a story of the form, because I take these to be the laws of physics, because I have good reasons for believing that these are the laws of physics, I conclude that I'm likely a Boltzmann brain, is self-undermining in a very straightforward way, because the second conclusion undermines the first conclusion that leads to it. The second conclusion, that I'm likely a Boltzmann brain, undermines the claim that you have good reasons for believing that the laws of physics that predict that Boltzmann brains outnumber natural brains are true laws of physics. Okay, so that can't be the right way to do it. That seems to me incoherent. I think Sean agrees with this, but I'm curious to hear.
Well, I do agree, but I think that there's something even more incoherent that most physicists who talk about the problem are actually thinking, because nobody thinks that they are a Boltzmann brain. Okay, like we all recognize that. It's the reasoning given for that conclusion that is a little bit dicey. I think that what David just said is very good reason to say, if you have a theory that predicts you are a Boltzmann brain, or let's just say a Boltzmann fluctuation, okay, like a random fluctuation into whatever situation you want, currently given our macroscopic knowledge, rather than a traditional thermodynamic evolution from a low entropy Big Bang, okay? If your theory predicts that you should think that you are such a fluctuation, you should throw away your theory. That theory is not very good because, for all the reasons David just gave, it's self-undermining or cognitively unstable, as he has said before and I have borrowed. But there's an even more simple and more naive argument that I think is what most physicists actually give, because they take this, they have a specific angle on this way to deal with self-locating uncertainties in a multiverse, large universe context, which is to say, we should reason as if we are typical observers within this very, very large universe, not typical observers conditionalized on our macroscopic situation, right? Just typical observers. So the usual argument given against Boltzmann brains is that if the scenario were true, in which there were random fluctuations and most observers that popped into existence were not even looking like us, but were literally disembodied brains floating in empty space, I can just look around and see that I am not a disembodied brain floating in empty space. Therefore, I have ruled out that scenario by data, okay? By experiment, by looking around. I think that that argument is entirely bogus, because we should not assume that we are randomly selected observers from a probability distribution that includes observers very, very much unlike us. Therefore, I think that what the argument David actually gave is the right one. We should not exclude Boltzmann brain cosmologies, because if we were Boltzmann brains, we would see a very different universe. We should exclude them because there's no internally coherent way that we could live in such a universe given our data and make sense of it.
But so let me push back on this a little bit. I of course agree with Sean's objections to what he characterized as the more usual thought among physicists, where we might be any of these observers. But and this connects up with the discussion we were having earlier about self-locating probabilities. I just don't think it's the case that that there's anything about adopting a theory according to which the vast majority of brains that are physically like mine are Boltzmann brains. Either in any way suggests that I'm likely to be one, okay, or leads to any kind of cognitive instability or anything like that. And the reason I don't think this is because I'm not pulled by these same a priori intuitions that Sean is pulled by about what the probabilities are about self-locating probabilities. Okay. So let me give you an alternative picture. Somebody presents you with a theory of the world. Okay. And you want to know whether this is a serious candidate theory. You want to know whether this theory is empirically adequate. Okay. What you're supposed to do, and I think all you're supposed to do, is ask yourself, does this theory support the existence of agents of the type I take myself to be? Okay. Agents who are reasoning properly about their environment, reasoning properly to conclusions about what the physical laws are, have good grounds for this reasoning, so on and so forth. And the answer in these Boltzmann, in the theories that we're talking about, are yes, I see how it can support agents like that. These agents will be supported early on in the history, shortly after the Big Bang, way before you reach equilibrium, and the period when there are many Boltzmann brains. I don't have, how shall I put it? Here's what's required. Here's what I take to be a crucial difference between something that succeeds as a skeptical scenario and something that succeeds as a serious candidate for a physical theory. Something succeeds as a skeptical scenario if it's the case that somebody says, prove to me that it isn't true, and you're unable to do that. Okay? The hypothesis that I'm a Boltzmann brain succeeds as a skeptical scenario. Okay? It doesn't succeed as a serious candidate for a physical theory, because a serious candidate for a physical theory entails an additional requirement, Not just that I can't prove that it's not true, but that the kind of universe this theory describes is a universe that can accommodate the existence of epistemic agents who might come to have good reasons for believing that that theory is true. Okay. These theories that have my brain in them, but also have lots of Boltzmann brains in them that are identical to mine right now. Does this theory accommodate the existence of epistemic agents who could come to have good reasons for believing that this theory is true? Yes, it does. There's one right there early on in the history of the universe, well before it reaches equilibrium and well before it's swamped by Boltzmann brains. The only thing that might make me resist that is some a priori conviction to the effect that I know what probability to assign to the claim that I'm this brain or that brain, given that I have no direct empirical evidence one way or another. I've never been able to understand the attractiveness or the reasonableness of these a priori techniques for assigning probabilities. So I don't see any cognitive instability. I don't see any obvious problem in adopting a cosmological theory which says that the overwhelming majority of brains that are in states like my brain is now in are Boltzmann brains sometime far in the future.
So I think this is good because this is a real disagreement. This is not a fuzzy disagreement. This is a hard one, and I think an important one, and it does put the finger on the self-locating uncertainty difference. So just to be super duper clear here, forget about brains, okay? Forget about fluctuations into a few kilograms of gray matter via that. No one cares about that. We're not those. We all know. The problem with these, and I think this was implicit in what David was already saying, the potential problem with a universe that is eternal and exhibits random fluctuations like the thermal fluctuations of gas in a box is not that these weird brains floating out there in the cosmos, but I can conditionalize on everything that I have seen about the universe. Like, I'm here, I'm in this room, I have data from the cosmic microwave background, okay? There will be an infinite number of those observers in the universe, okay? And of all of them, and I think it's just counting, like they are all in exactly the same epistemic situation. There's a complete symmetry between them. There's no way of saying that you're one or the other. And so to me, it's perfectly obvious that if that's the theory you have, you had better assign equal probability to being any of them. I have no reason to do anything else. But the overwhelming majority of those observers are going to look out at the sky tomorrow and it's going to be black. Because all of the photons that were coming their way were not really from the cosmic microwave background and from stars and like that. They randomly fluctuated into existence. And so if you really believed that theory, that's the prediction you should make. But you don't really believe that theory for various reasons that I would argue come down to cognitive instability. But I do think that this is why it is crucial to have a strategy for dealing with these self-locating uncertainties. Jim Hartle, who just passed away, great physicist, and Mark Srednicki wrote a series of papers where they said, I have a way of putting a probability distribution on these theories. Namely, there's probability 1 that I'm the good observer and probability 0 that I'm one of these bad ones that is going to see the microwave background disappear tomorrow. The problem with that is that they just made it up. There's no justification, no principled reason to do that, except that in their deeper heart of hearts, they don't really think that there are an infinite number of randomly fluctuated observers out there who will see the microwave background disappear tomorrow.
So this is a real disagreement. And look, here's very briefly and crudely how I would push back on this. There's how do I want to put this? what we do, it's a really important part of the way we evaluate theories. That, here's crudely the story of science. You're thrown into the world, okay? You open your eyes, you start looking around, you develop something. Of course, this is a mythical object, but it's useful enough for purposes like this conversation. You develop what philosophers sometimes call a manifest image of the world, okay? This is the image of the world that you have prior to scientific investigation and philosophical reflection. I don't know it's what normally developing 5-year-olds believe about the world or something like that. It includes beliefs like tables and chairs continuously fill up regions of space, which we know they don't. They're mostly empty space, blah, blah, blah. It includes all sorts of things like that. And the story of science is basically you start looking a little closer, and two types of tensions develop within this manifest image. Various pieces of the manifest image come to be in tension with one another, and also various pieces of the manifest image come to be in tension with new empirical discoveries as you start looking more closely at the world. So I don't know what. You put a pencil in a glass of water, and it looks like the pencil is bent, but then you slide your finger along the pencil, and it doesn't feel like the pencil is bent. And now you have two sensory reports, both of which you're used to trusting and putting faith in, and they're in tension with one another. And the manifest image is beginning to in very small ways come apart at the seams, and you have to figure out which of these to trust, and you have to develop a theory of optics which is going to explain why the pencil doesn't feel bent even though it looks bent, and yada yada yada. And you go on with this and on with this and on with this until, if things work out, you reach some sort of reflective equilibrium where you stop running into these tensions, okay, and then you're done, okay, and that's the sort of idealized mythological way in which science is supposed to work. And what I want to emphasize here is that it's a very important feature of this kind of progress, that one of the things that's playing an important role in your theory choice is something that I guess that Quine used to call a principle of conservatism, okay? One of the rules here is that you don't depart more from the image of the world that you initially naively had. You don't depart from it in ways that are merely gratuitous. You don't depart from it in ways that are unmotivated. Okay, because it's one of the few things that you have to hang on to. You have other principles that you want: simplicity, elegance, explanatory power, so on and so forth. But this principle of conservatism is going to be a really important thing in limiting your theory choices. You want to be able to tell the story of all the decisions you made once the scientific project is done. Well, why did you decide this? Why did you decide that? Why did you decide that? And it had better be that none of the decisions involved departures from the manifest image which you weren't in some compelling way pressed to make, okay? Which weren't merely gratuitous, okay? And one of the most important and fundamental things you want to hang on to is that your ordinary modes of reasoning about the past, about what to expect from the future, so on and so forth, work, okay? And what you're going to be looking for in entertaining a theory of the world is to see if this kind of world can support the kind of epistemic agent that you take yourself to be. Okay, the one whose inferences about the past, like the Big Bang, was 13 billion years ago and not 5 trillion billion years ago or something like that, is true, that these ordinary inferences that you make are to the extent that the scientific theory allows it to be the case, to the extent that this achievement of reflective equilibrium allows it to be the case, are true. So that the right thing for you to do, the right attitude that you should take towards your scientific theory is, oh, if there are a bunch of brains or a bunch of rooms or a bunch of earths that I see in this theory, some of which are in important ways more like the one I take myself to live on than others, my attitude ought to be, that's probably me. Okay? The only resistance to that is this a priori faith in these principles of self-locating probability. And I think those are getting us in trouble here in ways that there's no good reason for them to do.
I'll just try to say very briefly, I don't think they're getting us in trouble. I think they're just letting us rule out theories where most people in my current epistemic situation would predict tomorrow that the microwave background will disappear. And it's easy to get rid of those theories. There are other theories out there. So it's just a helpful kind of way of choosing between theories. I think that in this universe, in this randomly fluctuating universe, I think it's a little wrong to say, well, there are people like me who are in the aftermath of the hot Big Bang. There's other people who think that they're in the aftermath of the hot Big Bang, but all of their experiences are just randomly fluctuating. And there's, by the way, way more of them than there are that are actually in the aftermath of the hot Big Bang. But I'm not going to count them. I'm just going to assume that I'm not one of them and get on with my life. I'd rather just throw away the theory as a whole.